Okay, good afternoon, everyone. Today class is about sentiment analysis. So what does it mean? We read a sentence, and at the end, we want to say if it's a positive or negative sentiment. So let's see. You can do today, or you mean for your final project? Just make a video. We don't have time today, but next, let me ahead of time next time, so maybe we have good amount of time. So this is midnight at Punavit time. So, Punavit, can you read?
Yes, thank you.
So, from people here over Zoom, is it a positive? Do you get a positive sentiment from this sentence or negative sentiment? Do you think it's a positive? He was happy, so is it like it shouldn't be negative, right? So, oh, I'm not sure if the guys over there can see. So, but anyway, probably for understanding the meaning of this, the sentiment of this sentence, good is enough. Or maybe let's do. So, sorry, Punavit, I might cross your name, but I try not to. So Punavit is not a common name. So maybe we can exclude that. Is, you don't need to have it. A, you don't need to have it. You don't need exclamation mark. So with just two words, you can find the sentiment, right? Even student is kind of neutral. So good, the word of good is enough for you to find the sentiment of this sentence. So let me give you another example. So who's there? So I forgot to write. Is it? So is it? How should I write your name?
Just A
S W S W A
R U.
Oh, sorry. It's so wrong.
Sorry.
Okay. Isn't good in riding horses. Yeah. So on top of excluding some extra thing, maybe riding a stem is right, and horse. We go to the sum of the words. Maybe for isn't, is not. So riding and ride has the same sentiment. Horses and horse, same sentiment. We just go to the stem of the words because otherwise we should take care of so many words. We want to minimize the number of words that we want to take care of it. One way, excluding some of them that doesn't help. For example, for understanding the sentiment of this sentence, we know it's about Punavit, but we just care about is it a positive or negative sentence. So you can exclude Punavit because it doesn't seem to be a very frequent name. Same here, you can maybe exclude is. Surab is, I don't trust on your name, just close. So in doesn't help. Exclamation mark doesn't help. So maybe you said and ride is a neutral word. Horse is neutral. Good is a positive sentiment, not is negative. Maybe at the end, you would say is a neutral sentence because we have a positive and negative, they cancel each other out. Or in some methods, you might say, not a good case here, but again for today's case, because we do the lexicon-based sentiment analysis, we sum them up, all of the positive and negative are neutrals. If it's zero, means a zero sentiment or neutral sentiment. So one way is this one, because lexicon-based sentiment analysis, we do stem of the words, we exclude some of them that doesn't help, and there's some of the words that are positive and negative. Summation, if positive, you say positive sentiment, if negative, you say it's a negative sentiment. Any questions so far? Okay. Another one is similar to a traditional data mining analysis or research. So we use the stems as a variable. For example, give you another example. My name, Hamid. Good in cooking. So I exclude Hamid is in, and stem of cooking is cook. It's a neutral. Oh, sorry. It's cook and good, right? And let's say my dependent variable or y is positive. We already did a survey, so is in my train set, I already know my dependent variable. Maybe later I have a holdout set that I try to predict the dependent variable. So having said that, cook is a variable. First is good. Good is a variable, cook is a variable. And y, which is my sentiment, is my dependent variable. So this is my sentence number one. So row ID 1. Just expand it a little bit. So in the first sentence, or first, which is this sentence, cooking is 1. Sorry, good is 1, cooking is 1. Let's say here is about horse. And right. 0, 0, and sentiment is positive. So basically, I end up finding all of the words that are happening in my document. For example, for syrup sentence, we had good. We didn't have cook. We had horse and right, and it was, you can say neutral. Or you can say almost positive. Let's make it almost positive. So as you see, you find the sum of the words and consider them as a dummy or dichotomous variable. And same as a simple data mining project that I explained in the previous class, we try to predict our dependent value. Or you might remember regression. So in regression, you have some variables. For example, so y here, let's say positive is 1, negative is 0. So let's good times 2 plus cook times minus cook times 1 plus horse times whatever, right times whatever, and you sum them up. If the summation is 1, you say positive. If it's 0, negative. So similar to a simple data mining project, in sentiment classification, we try to stem the sentence to the words, then predict a dependent value. In Lexicon, which I explained before, we just sum positive and negative. If the summation is more than 0, we say 1. Otherwise, 0. So anyway, at the end, in the training set, we know our label. Is it positive or negative? And we do prediction. And in the test set, we can find the accuracy of our approach. So either lexicon or classification. So we either in the first approach, it's just summation. Lexicon. How much? Okay, so you sum plus and minus, and you have a prediction actually. And y of observation. It could be positive, prediction could be negative. So here you didn't predict well. You sum them up, but you not end up having a good prediction. In the classification one, which was the later one, I had variables, try to predict. Maybe I can say sentiment classification. Again, I could have positive prediction. Observation could be positive, so it's a right prediction. So in this one, I might just, SVM, neural network, or other algorithms. Much more complex. This one, you just sum up the positive and negative words, and at the end you would say, is it a positive or negative sentiment? I'm not sure if people over Zoom could see. So, what about here? Oh my God, it's very hard to see. What if I change the color? So, sentiment, lexicon. at least it's kind of readable. Sorry. So maybe next time I bring my tablet so it's more readable. So anyway, for finding the sentiment of a sentence, we have two approaches. One is Lexicon. You just sum up the positive and negative sentiment. And in the classification, use a machine learning algorithm to predict the sentiment. If you have some hands-on experiences, please go to over your Moodle and download two new workflow that I posted. So you see, first one is Lexicon. The second one, sentiment classification. Please download and load them into your Nine. I give you a couple of minutes to do that. Wait, could you read what was on the table?
Yes. If you use a green pen, I cannot read it. But the black pen is okay.
Okay. So please next time I bring a tablet, so when I write it on the tablet, you guys can see what I'm doing. Well, I also explained through this workflow. Hopefully, it makes sense. Okay, in this workflow, we do the lexicon-based sentiment prediction. What I mean, we do a stemming, we sum up the positive and negative words, and after summation, we decide is it a positive or negative sentiment. Then we look at the accuracy of our prediction. So go over reading the data. By the way, please watch the previous video that I made for a typical machine learning project. Have you had time to look at that video? Okay. So if you didn't look at that video, it might be challenging to understand what I'm saying today because there is many similarities. So click on reading data.
I think the previous video, one thing was missing, like whenever you were showing us the process table, that was not shown on the screen.
Oh,
Yeah.
that's terrible.
So you can see this page.
But when I click, you can't see this.
This also we can see, but whenever we move to the process and after the execution, if you go to the process data, what happened to the
Oh, you couldn't? Shoot. It should be some bugs in the Zoom. Anyway, so file reader. As you see, I'm reading a CSV file from 9. In your project, it might be you should browse to a file on your system. And also, I'm saying it has a header. So as you see, I have a movie index, a movie IMDb link. So with this column, we can get to a page in the IMDb website. There is a text attached to each movie, which could be very long. And at the end, we have sentiment. What does it mean? Somebody already read the text and put a label as a dependent variable. So here, we can use it for train and test. It's already, somebody already made it labels. It's like a dependent variable. Then, so sentiment was my dependent variable. I'm just saying that whenever in the sentiment you see a missing value, just exclude that observation. Do exclusion if it's missing on sentiment variable. So again, whenever we have missing values on dependent variable, we exclude that observation. So we can tolerate missing values on independent variables, but not dependent variables. So let me see. So people over Zoom, can you see the table that I just opened?
Yes.
Okay. So it was.
No, this is shown, but after you click the execute,
Uh-huh.
then after you click the right button of the mouse and go to the
Execute. Okay, let's do it again. So now I'm resetting this one. I don't say you're lying. I'm just trying to understand what was the problem. So I just reset that one. I right click, execute, then right click and go to this one, right?
Yeah, then we could like if you
So so people over Zoom, can you see now? Do you see a table that I just opened?
Yes.
Oh, it might be a bug that day. I'm not sure why. Anyway, thanks for letting me know. So, okay, now let me show the table again. So nothing happened. We just exclude the observations or the movies that we don't have any observed sentiment. But this is not good for KNIME to do lexicon-based sentiment analysis. We need to convert in the format that is easier for KNIME to do lexicon-based sentiment analysis. For the conversion, again, there is no mathematics behind of that. We just make it more friendly for KNIME. Look at the string to document. So here, we just identify some metadata. For example, saying that title comes from URL. The actual text are in the text column. They put a like arbitrary source name, and also we are saying that the categories are in the sentiment column. Use categories from column sentiment, and that's enough. So, and there's nothing over there. So with OK and execute. Now we convert our document to something that is more friendly for KNIME. When I right click and go to table, it just created a new document. And the label is just what you see inside each cell is just URL from here, and the only reason for that here I just said get the title from the URL. But there is so many information in that column. It's not just URL. You have the inside each cell, you have URL text and dependent variable or category. So look at the last module in here. Let me first run it. So in this one, I'm just saying I just need the document column because it's the column that NIME can work on it. So I can get rid of the previous one. Oops. When I right click and see the table, I just see a document column because it's the column that NIME can work on it. So for you, you don't see the other information, you just see the URL, but inside each cell, there is several information. So nothing much here, we just first got rid of the movies that we don't have the classification. Also, we convert our data to something NIME friendly. So the next group of modules or meta node. So you might remember seeing my previous video. When I expand it, you can see whatever it was inside the node, but it's much more convenient to group them into a meta node. So it will be more organized. So I double click, go to this meta node. So first of all, in this pre-processing meta node, we get rid of numbers, we get rid of punctuations, we get rid of subwords and convert all of them to lowercase. So look at the first one, number filter. We just said, if you see any numbers inside documents, exclude that. In the second one, we see if you see any punctuations, exclude it. Because they don't bring any, they don't help us to understand the sentiment value. For stop words, again, we don't need them, exclude, and case converter. As you see, I just said convert them to a lowercase, execute. And all of them are happening on document, which is not user-friendly for you, but they are NIME-friendly. So you don't see what is going on there, but inside each cell, you got rid of numbers, punctuations, and stop words, and converted to a lowercase. Okay, any questions so far? Hmm? Okay, let me see your. Let me see module name again. Just
Yeah, so that's why while I was opening, they were showing like you need to update some.
oh yeah, update.
I think that might be the problem.
Just update.
Yeah, I think
I wait for you next update.
because we disturbed.
So if your NIME is not updated, you don't see some of the modules and you cannot follow me. So just waiting for your friends to update their NIME. Did you update your NIME?
Yeah, the same version.
Oh, it said another installation is in progress.
Yeah, Professor, I think it's okay because of the update. There's a problem because of the update. Yeah.
So please update your NIME, especially text to a string. I think it's one of the modules that you need to update. So anyway, where was we? Okay, wait a little more, but please keep finishing the first two meta nodes of reading data and pre-processing. So in the next step, while your friends are updating the NIME, first of all, we should know which words are, or which word stem are positive, which one are negative, right? How we can do that? Basically, some people studied all of the words in dictionary, end up saying which one has a positive and which one has a negative sentiment. So what we do, we import two dictionaries, one dictionary for positive word, another one for negative words. So look at MPQA dictionaries here. I have two file readers. One of them is associated to positive sentiments, words with like accept, abundant, able. These have positive sentiment. Let me open the second dictionary. Abandon, abject, absurd, abuse. These are negative sentiments. So what we do, we need to assign those dictionaries to the words that you have, to the basically document column that you already created. So what we do, we use it with dictionary tagger. So we need to tag the word stems in each sentence if either they're positive or negative. So there's a module. So tag type is sentiment. Value are positive because they are coming from a positive dictionary. And dictionary column is word. Again, because when I imported here, the word is column associated to positive sentiments. And the document column is just document that we created. So basically, previously, we convert all of those link, sentiment, text into a document column. So let me run the first one, execute. Is it again dictionary tagger? You tag the words that are used in each text. Again, second one is for negative sentiments. Any questions so far? Okay. So nothing very like crazy. So first we just convert to the NIME-friendly format. Then we just tag the positive and negative words. Let's open this one. So what we do, we create bag of the words from each line of the document column. So let's just run and see what happens. Now I have a new column of term. So these are the terms that are used in each document. Look at the link, look at the document column. It seems this link or title is repeated several times. Do you look at here? Everything, these 34, these are all just about one movie, but it just repeated based on how many terms that are used in each of them. So in that text file, we had 34 terms. So what it does, it just finds the words that are used, except for the words that you excluded, like numbers, the stop words. What was that? Another one. I don't remember. So anyway, so what we do, basically, we divide each sentence or each comments into several comments, and the only reason that we repeat it several times because for each term we make a new row. So again, for HTTP, new row, website, new row, Gearfight, new row, follows, new row. So all of these first 34 terms are in the just one movie comment. And if you go there, there is several others. As you see, everything from here to, let me go to the, look at the numbers, it's 7640. Everything 7640, it's up to here. So these highlighted one are the talking about the terms or words associated to the second. So with bag of words method, we divide each comment to several words that are created that comment, except for the words that we already excluded or characters that we excluded. So now what we want to do, we want to find frequency of each term. So let me just execute. So in each comment, you can see each word or each term repetition. For example, in the first movie, there is 2 girl fight, 2 follows. There is just 1 HTTP. There is just 1 smell, 1 sweat. So you count how many times a term repeated in each movie comment. Do you remember we talked about TF-IDF in the last week? So we found term frequency in each sentence. So it's something similar to that. So far what we did, first, import the data, exclude the characters that are not interested. Then in each comment, movie comment, we tag the words based on if they are positive or negative from the dictionaries that we imported. Then we count the frequency of each term within a movie comment. Now, see what we are doing. So let's go to the first meta node on top. So let me first run it for you guys. So do you see what happened? So we just changed those terms to the string, and we put the tag type as a sentiment. What happens if I go to the table? I have a new column of sentiment that shows it's the tag. So HTTP doesn't have any tag. Why?
Because it's not in the dictionary.
Yeah, it's not in dictionary. Intuitively, it's not positive or negative. It might be positive and negative, not in the dictionary too, but look at gear fight, is not in dictionaries. You might, for some people, might be positive or negative, because it's like, or followed is neutral. York doesn't have anything. Amateur. Even amateur could be negative, but since it's not in those dictionaries, the tag is not defined in that dictionaries, you don't see any positive or negative. For example, if I want to find the sentiment of first movie, which is everything from here to 75. So these are all about the first movie. You can say there is 2 positive, 3 positive, -2 negative. You can even do it manually here, right? So let me open it again. Here, we convert tag to the string. So we already know that our terms are tagged from the dictionary. Now we convert the tags to a string for us. So we want to see that. It's already within the non-friendly format. We cannot see that. We add a module of tag to a string. We want to convert those tags that we are not seeing them to a column that we can see. So now we can do a pivot table. So let me see why we are using pivot table. So now I want to sum up all of the positives and negatives. How I do a pivot. Have you heard about pivot tables in Excel? Okay, so I'm pivoting by movie ID, but movie IDs, which is those like, let me show it here. If I do pivoting by these names, I can find how many are positive, how many negative. So if you're not familiar with pivoting, please just search for see how to make a pivot table in Excel, so you can easily understand what I'm talking about. So people over Zoom, are you seeing my name? It's weird. I'm not sure if they can see.
Yeah.
Okay, that's great. So in pivoting, so I'm just working with a document. It's only one that I need. I pivot column is sentiment, and the aggregation is just summation of frequency. So TF-ABS is the frequency of each term. I'm just summing them up. So if you run this pivoting, right click, pivot table. As you see now, we did aggregation over sentiment, and it was summation. So you can see in each how many positive or negative sentiment or tags. It's better to say tags. So how many negative and positive tags we have in each sentiment. For example, first one, 37 minus 6 is 32. Second movie, 4 minus 4, 6. Third movie, 64 positive, 27 negative. So the first three are, they have very positive sentiment if you do like simple lexicon. And missing values, we just say if you see, if there is no numerical value, impute with 0. But if there is no text, don't do anything. So the numerical value, including summation of or aggregation of positive and negatives, are imputed by 0 if there is nothing there. And 0 is fair enough because probably there is no words, no meaningful words associated to them. So let me just execute. So what happens so far? Again, document column is just a one column, but it has all the information that NIME's needed, but it's not user friendly. So we don't see what is inside them. We just see it like IMDb link. We did pivoting based on movie IDs, based on or the name or link that they have here. We know how many positive and negative tags are in each comments. So the next step could be just calculating the lexicon-based sentiment. Okay, it's what happened on the top side. In the top meta nodes, what we did a pivoting, and for each movie, we found how many positive tags and negative tags are existent. Any questions so far? Okay, great. Okay, let me go back to the first, the earlier meta node, right click and output. So in this one, what I have movie IDs or movie IMDb link. I have term and their frequency, just simple frequency of term. I'm not sure if they are positive or negative. We can do a group by IMDb link to find just how many words are in each movie or how many terms are existed in each movie. Maybe there's another way you can say, okay, we have a positive, how many positive tags and how many negative tags, you can sum it up. So that's fine. There's not just one way of doing that. So it's one way. I just want to do an aggregation based on IMDb link. So, but you are not limited to that. So for finding how many terms are existed, you can go to the last meta node and just sum up the positive and negative and get the summation. Anyway, there is another thing too. In the previous one, we sum up the positive tags and negative tags, but some of the tags are not either positive or negative. But here, in terms, we sum up all of the terms, either positive, negative, or unknown, because they are not defined in our dictionary. So here, what I do, I group by, is that? Okay, I group by, I do summation of TF ABS, which is frequency of term frequencies, and group by document. So let me just run it. Let me right click. So you just see how many terms are associated to each IMDb link, or which are, instead of IMDb link, let's call them movie IDs. So we know how many positive, how many negative tags, and how many terms we have. So again, we are getting one step closer to finding the final lexicon, which happens in the calculate score meta node. So it has two inputs. The lower input, which comes from aggregation, just give me information associated to how many terms are existed. The upper one, the upper link, brings the information of the tags, how many positive and how many negative tags are existed. I joined these two based on the movie ID because I want to join information about their tags frequency and total terms frequency. In the joiner meta node, I'm just saying join them, or you can do inner join, that's fine too, I mean. So hopefully it makes sense, but inner join is enough too, but anyway. So we join them based on a common column ID. Do that, execute, right click, joiner table. So look at here. For example, in the first movie, I have 6 negative terms, 37 positive terms, or tags. I think tags is a better thing for that. So in first movie, I have 6 negative tags, 37 positive tags, and 205 terms. So it seems that many of them are not existent in our dictionaries because otherwise the summation of tags and terms should be same. So with column rename module is extra. It's just for renaming the sum of the columns. But for example, I'm changing to positive word, negative words, and all words. Do you see positive plus sum TF ABS? I change it to positive words. Negative plus sum. So we are just renaming columns basically. Not a big thing. So let me just execute. Now math formula. So look at here. Here I'm calculating the lexicon value. I'm just saying positive words column minus negative word columns divided by all words. And make a new column with append. You make a new column. And this is arbitrary name. You can change it to any name that you like. Okay. Right click, execute. Now look at the value that we just made. Look at output table. Look at them, almost all of them are positive. You see? There's few negatives. Let me just sort them. If you click, then you can say ascending. So first you see the negative sentiments, maybe up to here. I think it's just less than 20% are negative, and the remaining either 0 or positive. So in your project, maybe you can, if your final project is sentiment, let's say you can stop by this one. You can just say, based on this formula, it seems that most of my comments are positive, but you can be more picky. Again, it could be enough for your final project, but let's dig in more. So what I want to do now, I want to say, look at the mean of the score or average score. Any movie score more than average or mean is a positive sentiment. Anything less than that, a negative sentiment. So let me stop share and hopefully your friends can see. Right now is skewed to the left. For people over Zoom, I think it's probably skewed to the right. So negative. So for them not to messing up, so it's skewed to the negative values. Most of them are positive. Again, it could be enough. You don't have to do that. You don't have to do the remaining, but it's a good practice. So what I'm saying, mean is somewhere here, right? Bless you. So mean is somewhere here. Instead of simply saying positive is positive sentiment, negative is negative sentiment, I want to be more picky. So I would say anything more than here is a positive sentiment. Anything less than this, negative sentiment. Later I explain another reason for that, but I just want to be more picky. Instead of just saying more than 0 is positive, I would say more than mean is positive sentiment. But again, you don't have to do that. Maybe you have to. Let me just talk a little more. So now I want to calculate mean and say everything more than mean is positive. So look at group by. In group by, I'm just saying that when you do aggregation, okay, it was like this. Let me just remove all. In the aggregation tab, I'm just adding sentiment score twice. The first is mean, the second is the standard deviation. You don't have to do, even mean is enough. But anyway, so click OK, execute. Now, if you right click and go to group table, you see the mean and a standard deviation of sentiment score. Again, for us, mean is enough. We don't have to calculate the standard deviation. So what we do, again, we do group by over sentiment column. And the aggregation function is mean and standard deviation. So now it's kind of weird. Now you cannot use it directly. You need to do a conversion to convert that mean and standard deviation numbers to a variable. For this reason, I have table row to variable. This brown module just convert your table to variables. As you see, there's no anything there. You can just leave it as default. Right click, execute. So now I have mean and standard deviation as the new variables. So again, with group by, I found my mean of sentiment. With table row to variable, I convert that mean to a variable because later I want to use it as in a formula. In my formula, I want to say this should be more than that variable. So it's the reason I use this one to convert that value to a variable. Mean value to a mean variable. Let's see, the connection is now red. and just connect it to this corner. So now look at the rule engine. Let me just delete everything. So now I want to say sentiment score greater than equal. Look at this one. Now I have a mean sentiment score as a variable. I think I messed up with formula. Yeah. So I'm saying sentiment score greater equal to this one is positive. Otherwise, it's negative. It's not look like any programming language. It's a weird script. But the only point that I look at here, I am created the mean sentiment as a variable here. So if there's another way, you can manually find the mean. For example, here, let me just group by. This is the mean value, 0.071. I convert this one to a variable, then use the variable here. Instead of this, you can put 0.071. So you can either use it as a variable there, or as you can just type it. Let's see. Do you see? So instead of putting this variable here, I put the actual mean. But I think it's a good practice to first find the column mean, convert it to a variable, then use it here. So right click, execute. Let's see what happens. So sentiment score and sentiment prediction. As you see, 0.034 is less than 0.071, right? It's less than the mean. It's the reason it's negative. 0.067 is less than mean. Mean was 0.071, so it's negative. So later we need to use it for calculating the accuracy. Now we need to extract the actual tag, sorry, the actual, oh no. Now we want to extract our observed value. So do you remember it's already all the movies are categorized as a positive or negative? So let me go back. Early here, it's already categorized here, right? What we did, we categorized here as sentiment prediction. Now we want to compare with the what it actually was, then see if we have how is our prediction. So here I execute, and let's look at the outcome. Sentiment score. From sentiment score, we found the mean, anything more than mean positive, and we consider as a prediction. Then this is the actual class value or actual category of the movies. It's what we predicted from our sentiment analysis. So we have prediction and actual value. We can find our accuracy. I think, okay, I forgot to say here. So when I used this script for making formula, as you see here, I said, put the calculation into a new column of sentiment prediction. Do you see here, append column? I append a new column of sentiment prediction. This sentiment prediction is coming from here. Anything more than mean, positive. Otherwise, negative. Yes? Is a weird programming language. So it's just say if first, otherwise if second is true, it's negative. It's just a if else. Just it's a very weird programming language. You know, it's not a very efficient way. I know it looks very weird. What does true equal negative? Greater, true equal, like equal greater than negative. You know, I know it looks really weird. It's just if else. If first condition, otherwise the second condition is true. And if the second condition is true, which is the opposite of the first one, so it's negative. I know it looks really weird. I accept that. Okay, so far we did prediction, and also we take out the actual value. So the actual value, again, let me go back here. The actual value was inside the document column, which is NIME friendly. We couldn't see that. With category to class, we take out the category was inside that column. There is something extra here just for looking good. You can delete that. But as you see, I'm just saying in prediction, anytime you see negative, make it red. Other positive, make it green. Or you can change red to blue, or positive to maybe yellow. You can just change the colors. That's fine. I mean, it's something extra. So let me just run it so you can see. So positives are yellow. Negative predictions are blue. So anyway, you don't have to do that. It's something, one extra step. And the scorer is similar to previous ones. The first column is our prediction. Second column is the actual value. First column represents the real class. Or first column is the real class, sorry. Real class was document class. Second column is the prediction. So sentiment prediction. Please just change these two. So if you look at the documentation on the right, the second column is what you predicted. The first column is the actual value. So anyway, first is actual value, second is the prediction. Okay, right click, execute. Accuracy statistics. 74% is accuracy of our prediction. So, or overall accuracy. So what you can do in the next step, maybe for you 74 is not good. Go back there in here, and maybe instead of the mean of column, you put like mode, or you put 0. You say I think 0 is better. What happened actually previously, it was 0 and the prediction was not that much great. I was thinking, okay, instead of 0, let's calculate mean. Maybe now you have a better prediction. I just said threshold is not 0 anymore. Put mean. Might got somehow better. So it's the reason I did that. So as a practice, try to improve the prediction accuracy. You should have short assignment. You don't actually, it's not very difficult. So try different ways. I mean, the easiest one, just come here. Maybe here, instead of, you need to put mode. There is no mode here. Maybe here, group by, you change aggregation to median. Sorry, median. Mode is not good. Median might be better. Or Any. I think median is the only one that is good to go. So two things as your assignment. The first one, change threshold to 0 to see if it's improvement or it make it worse, or change threshold to median, then see the results. And in the Word document, put your results for me. I post the assignment later tonight, but it shouldn't be a difficult assignment. You just play with the threshold. For making median, in the group by, you should, instead of aggregating based on mean, should do based on median. Otherwise, you cannot use it here. Also, for 0, you just delete it and put it 0 and see what happens. But as your assignment, or maybe you change it to something else. Maybe you said mean plus 1 standard deviation. So maybe mean plus, or 2 times mean, or 2 times median. Try 2 different ways, or you put 0. So try 2 different ways to improve the prediction of this prediction. And just in the Word file, you can just take a snapshot from your final score and just explain me what scores. You can just copy and paste this one and just say it was your change and it's what you get from prediction. So as you see, machine learning project or data mining project is something back and forth. People they first look at the prediction performance. Maybe they are not happy with that. They go back to other steps and change some part of the models. So let me post the assignment even now. Okay, week 7. Lexicon assignment. Study the lexicon. Let me see here again. So I don't care if you can't, just try 2 different ways and report it. So try 2 different ways. So we have 1 week. Or maybe you can Google it, find another ways. You don't have to just play with the threshold. There's so many other ways. Just Google how to improve lexicon-based prediction. Maybe instead of that dictionary, let me just, it's too much. 1 week is too much. So let me just make it like 5 days. So in this 9, maybe I use this dictionary, maybe you import another dictionary. There, you can find some online dictionaries. And so here, when you import the dictionary, you browse somewhere in your folder and you just, you can just bring other dictionaries, and maybe you can have better, you can have some improvement. Anyway, that's for today. I hope you enjoyed. Any question from people over Zoom? So in the next class, I opened the second one. So we didn't have enough time for sentiment classification. So let me also explain these things over Zoom again. So before next class, we do sentiment classification. Basically, still we predict the positive or negative, but using machine learning algorithm. Here, we just sum up positive and negative tags and end up saying if it's positive or negative based on threshold, either 0 or mean. In the next one, we use variables, we use words as variable and try to predict our sentiment based on machine learning algorithms. And actually, it could be a very interesting topic. For example, when you do machine learning algorithm, you not only just predict positive or negative, you can predict the probability of being positive or probability of being negative. So let's say and you can use it for predicting the next US election. And people, every year people do that. So they read the people's online tweets or comments or anything that they do online. And from this sentiment of the tweets, they can say in each state what's the people's general idea about a certain candidate, if it's too much positive or too much negative. So you don't have to go call people one by one and ask about their idea about the president. You just read their online comments or documents or whatever. Using sentiment analysis, you want to see if how much positive or negative idea they have on some or you just have two candidates on each of the candidates. And I think every election there is a guy who can accurately predict the result of elections by just doing a sentiment analysis, but a very advanced one, you know. So there's a ocean of techniques and approaches that you can do a very good sentiment analysis, especially for people in the marketing. So actually, I have a sentiment analysis paper under review, and we look at people's comment on hotels. By reading people's comments, we can understand which hotels are performing better and what is the issues. Let me talk about it more in the sentiment analysis, but you can easily use it in the marketing or for people in finance. What was your major? MBA? I think you can do something in both of them, but for finance people, you can read people's tweet or even news. So you can, I recommend to do something for your major. For example, for finance people, you can just take news, financial news, read them, and guess what happens tomorrow on certain stock price. Maybe you can say, based on my sentiment analysis, I guess tomorrow Apple would go up or down, and you can sell or buy your stock today and make money for tomorrow. So you see, there's so many applications for that. Okay, if there is no question, that's for today. It's a very interesting topic. Hopefully, next class we go to the classification ones, and you can see there are so many applications. Okay, great, and have a great evening.